I'll start recording and then I'll share my screen. Okay, so yeah, so yeah, give me a thumbs up if you see what I am recording, if you can see my screen. And then nice. So let me get my links together. I have my notes here, and yeah, so I think we are good to go. So welcome guys, my name is Jovan. Jovan Mwesugwa. I'm a software developer and I am a co-founder of Shukuru and OneRamp, which are Web3 solutions, applications and projects built on top of Web3, and their main goal is to majorly link the world of mobile money, the world of banks, the world of what you call traditional finance with Web3. So Shukuru is a mobile wallet, a simple mobile wallet application that is built on top of the blockchain, and it allows us to make cheap transactions, very cheap transactions, in terms of saving, in terms of payments. I think it's the cheapest. So we also have utilities whereby you can buy airtime, you can buy data using your Web3 money. So currently we have Celo Dollar, and we also have Bitcoin Lightning on Shukuru. So it is something that can allow you to deposit and withdraw using your mobile money so that you can start enjoying the world of the blockchain. So we are working on the update that is going to have deposit and withdraw for both Bitcoin and Celo Dollar. So that is in the works, and also we are also working on the iOS version for Shukuru. So behind the scenes, what Shukuru is doing is using the OneRamp APIs. So what OneRamp is an aggregator. It provides all these very nice APIs that wallet providers, that applications, the exchanges, the Web3 software wants to use to allow their users to buy using crypto, and then buy crypto using their mobile money, especially stablecoins. So they give you a product of suits of on-ramping and off-ramping, majorly using CSD and Bitcoin Lightning. So Shukuru is using this, and it also has a self-checkout widget, what you see here. So maybe you have your own wallet and you want to on-ramp straight into your wallet. This self-checkout widget allows you to do that. So you just connect here and enter your wallet details and make a payment using your mobile money, or withdraw using your mobile money, and OneRamp will relay the money accordingly. So it has buy and sell features, both of that. So yes, moving on, we are entering the last version of, I think this is the last day of the build on Solana with Achor. We covered quite a very big ground. We did Rust. We started with Rust basics. We came through Rust. We learned data types in Rust. We covered ownerships. We covered structures. We covered functions, and then to the point where we began building on Achor. So the last few days we've been building our small program on Achor, and yesterday we were able to deploy our first program on Solana. And yes, so yeah, it looked very nice yesterday. So today I want to show you how we can maybe extend our program. When I say program in Solana, they call them programs. I think the Ethereum people call them smart contracts. So when I say program, just now I'm talking about the smart contract and the application. So in Solana, in our program, we want to, today I'm hoping we can extend it. Maybe we add some few functionalities, and then we end with some few tests. So I want to do some automatic testing because I think it's one of the most recommended way of building programs on the blockchain is you write and then you test as you go. So that's the architecture I want to push with this, and hopefully if times allows, I hope we can get through there. So I'm going to open our development environment. Maybe let me close that. We are developing in the Solana playground. So I'll go and open betasol pg.io, and this is what we have so far. So I'll have to change this to light mode, I believe, for the cameras, and maybe expand this to full length. So yes, so yesterday we had this create hero. What create hero does, it basically creates the hero and adds it to the blockchain. We added this author key, and then we calculated the size and space each account has to offer, and then here we created the mutation function that is able to create a hero. So I want to move off of that, but before I do that, I think I'll first have to, let me first extend that. So I want to continue on building on this, maybe create a few more functions, and then also I'll show you what happens the other side. So we have the create hero, like following the CRUD credentials and the CRUD functionality, where we have the create, and then we have the update, then we have the read functions, and then we have maybe the delete and the traverse, all of those. So it's what I want to go with. So I'm not going to create all of them, but I'm going to show you the main blueprint where you can push and see how you can achieve, so that you can go back home and maybe extend on this smart contract the way you want. So by default, remember we had this account, we made it public. The moment we made it public, by default, Achor is going to give you these fetch functions inbuilt for you. For example, if you remember when we deployed here, the program gave us this. So this is possible because we made this structure public. So if I press fetch, you can see that the users that we created are all going to be retrieved, and the fact that we made it public is the reason why Achor was able to have these functions for us. So it is inbuilt. You may not need to create separate functions to retrieve. It comes out of the box the moment you have this as public. But yeah, you may have some use case. Maybe you want to retrieve, maybe you want to play with the data before you return it. Then you have your own separate fetch function that may not be, maybe you don't want to use what Achor has inbuilt. So it has fetch all, and it can also fetch a single. For example, if we use, maybe let me expand this. So if we use the public key and then we come and paste it here, it can also return the required. So yeah, that is inbuilt, and I don't think we have the need of building that. I want to show you another function, maybe to solidify the whole concept. I want to show you another function, maybe an update function. So we've seen a create function, maybe we can extend that with the update function. Yes, so okay, now remember we talked about everything being an account in Solana and Anchor, and our account here is hero, and then all these functions are going to be playing around and mutating hero. So we do not need to create another account for hero. The only thing that we need to have is create another function that is going to mutate hero. So using the same convention, I'm going to create maybe under this, and then I'll have my macro. So derive accounts. So we talked about this macro yesterday, that this macro gives you all the boilerplate code that you need when you're creating this functionality. So we do not have to write accounting system, we do not have to write signers, we do not have to think about security, we do not have to write all that boilerplate code repeatedly. By just adding this macro here, it gives us everything that we need outside of the box. So if you've written code in Python, I think in Java, if I'm not mistaken, they have things that are similar to this. They're called decorators. I think in Python it's something like this. Then maybe it will look like something like derive account, and usually it's on top of a function. Yes, so maybe it is on top of a Python function like that. So yeah, it's something similar to that. So so we have that, and then we want to keep our code predictable and our naming convention straightforward. So we are going to call this, remember we want to make it public, so we want to create a struct and we call it update hero. So we have that. Don't forget the lifetime. Remember we said that we need to have the lifetime, and we said what this lifetime does is to let Rust know that, hey, everything inside this lifetime in the struct is going to have the same lifetime. It's going to be valid as long as this struct is valid. So they share the same lifetime. So the word info is not mandatory. I've seen people call this T, I've seen people call this J, maybe what. It's a generic. It can have any other name, but usually the recommended way and the most common way they do it in Anchor is to use this info. So I'll recommend you put it as the same. So now what do we want our hero to do? We want it to update. What kind of fields do we want it to update? So when you think about Web 2, the way Web 2 works, maybe you have your database, your MongoDB, or you have your Postgres, and you have your mutation functions. Sometimes there's what they call patch functions, and there's what they call a put function. So a patch function will update specific fields. For example, if I have a hero model inside my database, what patch does, it will only update the name, or it will only update age, or two of these, or three of these. A put function is similar to patch, but usually what I've seen people do is they throw the whole data with only the change. So maybe we want to change the age, so they throw the whole default object with the same information while only changing the age. So it is the same thing that I want to do, because I want to keep it very simple, such that a user can just call one function while passing in the information that they want to change, because I don't want to create a separate function for changing age, for separate function for changing bio, for separate function for changing age. It will just be under one put function, and only the updated fields will be changed and the rest will be passed in as default. So it is the same logic that I want to go with here. We'll treat it as a put function. So remember we talked about what we have to do. The first thing that we have to tell this structure is the account. What are you going to first, what are you going to affect? What are you trying to change? And that is the account. So the first field will be hero, because we are going to play around with the hero, and it goes under the account. and then it has the same lifetime, and then we pull in the structure here. Cool. So now we have access to that. And then remember we said that every state changing, every command that you write has to be paid by someone. So here we'll come here and we'll add the signer. So we'll skip the same convention and we call them the author, and then we say okay, this is the signer, and then it has the same info. So we are not creating something new like this. We are not creating something new. We are only going to update what is already there. So Solana does not need to have the system program because it does not have to identify what is new and maybe to create something new. It's just updating what is there. So we do not need to pass this here. So we can leave it at that. And then we are not done yet. So currently, remember here we had this attribute that told Solana, hey, you know what, this is an initialized function. Sorry, this is going to initialize a new hero as a new program, and then it's going to have the payer. Someone is going to pay for that, and it has to have that space. So we do not need to have, you do not need to create that again. We have already done that. We know that hero has already been there, the rent has already been paid for, and everything is there. But now we have to tell Solana that, hey, you know what, this function has to be changed. Remember when we said that everything in Solana is an account. Even programs are accounts. The only difference with programs is that they are executable. They can change state. So the way we can, because here right now this is just an account, so it does not have, Solana does not know if it's going to change. It does not even have permission to change it. So we have to tell Solana that, hey, you are going to go inside here you are going to go inside the account. Sorry, you're going to go inside the hero, and you're going to do some state changes. You're going to change a few fields here. So we have to tell Anchor right from the start that, hey, that is what is going to happen. So fortunately, we do not have to write a lot of boilerplate code to achieve that. So we have another attribute in Solana using the account. So we go and write account, and then we tell it, hey, this is going to be mutated. So remember what we did here for the author. We said that we are going to change the balances in the author. It is the same thing that we are telling Solana that, hey, we are going to change the fields in hero. Yes, so after doing that, another thing that we want to prevent is we want to prevent anyone from changing the hero name. So if someone created the hero, they will have to be the only one to change the name. So we are trying to reserve the permission for the only creator. So you can write boilerplate code that can check for those rules and maybe extract the author and then block the permission if they don't match. But fortunately, Anchor has another attribute that allows you to hide all of that, and it does that for you outside of the box. So it's called has1. So if I come here and I write has1 and I tell it, hey, this is the author. This is the author, and this is the only field that has permission to change what is there. So now that is done, we have our update hero defined. In our context has been defined properly, and we do not miss anything. And now we can go ahead and create the function that is going to do the business. So remember we said that all functions are going to be defined inside here. So when you go and expand your knowledge on building Solana programs, you will go and expand maybe and see how they do maybe modulars and separating these files. You find that most of the time that these structures, these accounts are separated in their own file, and then these maybe are put in their own file, and then this is put in their own files, just to organize your code base. So yeah, maybe if you want to expand on that, you can always read through the Rust documentation and see how you can do that. But I want to keep this very simple, and I'm going to just throw everything in the same field. Yes, so after the create hero, we are going to create the update hero function the same here. So I'll come here and I'll put it under the create hero. So it's a function and it's called update hero. Remember we said that we tried to keep the same namespace. We try to keep it very simple. We try to keep it organized using the same, not the same, but the similar naming space. So here it is camel case, here it's going to be snake case, so that we know that, hey, this is going to be communicating with the context of this. Nice. So we come here and then we have to pass in the context as ctx, and then we say that we need to have the update hero pass in there. Nice. So another thing that we have to do is, remember we said we are going to treat this function as a patch function, as a put function. So maybe in your front end you have maybe some logic that goes to and looks at the information about a single user, and then when a user changes a field inside that hero, you retrieve that and then you pass it. You pass all the fields there, and then you just change what the user changed. So by that use case, that means we are going to enter the same fields as we had here. So we will have name, and I want to do something a little bit different here, just to show you maybe another data type that you may be interested in. So remember here we are passing it as a string, straight as a string, as an i32. Another thing that you may stumble upon when you're writing Rust and Solana, you may find that sometimes this data is wrapped inside an option. So it's maybe you find something like this. So I'm going to cover option in the next step, so just bear with me. I'm going to cover it in a bit. So I'll come here and I'll wrap age in an i32 as usual, and then I'll come here and then I'll pass in the bio, and I'll also wrap it in an option of a string. So remember we said that this function needs to return a resolver, so we'll come here and return it in a result. Maybe keep it empty for now, and then we have this okay here. So we talked about this option. We didn't cover the option that these are one of the built-in data types that are added inside the like outside the box, inside the box using Rust. It is similar to what this one is. So what this one does is it wraps, what option does is that it wraps your information inside this, and then it helps you to handle cases where you may not have a value. For example, if someone calls this function and they just enter an empty string, maybe they don't pass in value, what option does, option will wrap that and it will return it as a none. Get, so it returns it as a none if it's empty, or it returns it under a sum, and then it puts, maybe the name was Jack, so it returned the name with Jack if it's there. So it's doing some nice error handling outside of the box. So yeah, so you know that whenever you find a none, that means the data is not there. So using that, I want to use this same thing to do this thing of checking the characters, but I'll get there. So the first thing that we talked about we are going to first get the hero account as usual. So we come here, we get the hero, and we said we have to find it under the reference of mute ctx .account.hero. Nice. So we have that. So we have extracted our hero account there, and we can now play around with the fields that we want to change. So the first thing that we are going to do is we need to first pull out these values. So let's start with name. So we know that if name is inside, is going to be wrapped inside the sum because it's here, it's inside the option. So we'll come and extract it with sum, and we'll put it in a variable. Maybe we'll have it in a named variable, and then we'll play around with it. So what this let is doing, it's pulling out the name out of sum, but also I want to cache the character limit. So I'll come here and maybe I'll put it in name, and then inside here I want to check and see how long is the character. Remember what we did here? I want to wrap this whole logic inside a closure and then capture the result from there. So this whole if, so the way you can do that is you can say if let sum, and then sum, we extract out the name, and then we set it there. So what this does is a closure. So I've combined this variable, and I'm checking to see if it's there, and if it's there, I'm going to do all the I'm going to do logic inside this if clause. So it's just as a way of chaining everything together. So the fact that this sum has been pulled into here, I'm going to come and have our logic that is going to check for the character limit. So I'll say if name is name.chars dot count is greater than 50, and then here we're going to throw our error. If you remember our error here from our enumeration, which is name too long, so it's error code. If I can find the line of code, so here it's error code, get that and put that inside there. So we know that if name has been powered here, we are going to check for its character limit, and if it's okay, if it does not have any issue, then I can add it here. I can update its field on the hero account. So I'll come here and I'll say hero.name is equal to the name that we extracted from here. Cool. So we've pulled we've pulled the name from our option. You do not have to do it like this, but I think it's the recommended way of writing Rust, because one of the things that you need to think about when you're writing Rust code is you need to always think about, how am I going to handle my error? How am I going to make sure that my program is not just throwing around panic buttons and everything? So you need to always think about that. Handle all the use cases, and the good thing is that you do not have to write a lot of boilerplate code. So if I was doing it in something like TypeScript or JavaScript, you'll find myself doing this try and catch, maybe seeing all these variables and seeing if it's empty, and I'm looking at length. But the good thing with Rust, it comes with this option, and it wraps it for you without having to write extra stuff. Nice. So we have now set the name. I want to handle the bio next, because age is a little bit straightforward. So I'll go and look at the bio. So I say I'm going to do the same logic. So if let sum, so if the bio is inside sum, come here and set it here, and then I'm going to put it in this closure, and I'll say if bio.chars.count is greater than 240 characters, and then we'll return our error code. I'll come here and pull it from the enum. So I think it's error code here. So error code dash dash dot into. So now we know that it is caching. The moment it finds that bio is longer than 240, it will throw this error, and then after throwing that error, and if it's okay and we don't have any issue, we can set it to our bio account. So bio, set that there. And nice. So now if the user has changed the bio, then we know that the bio will be updated. So the next thing that we are going to do is we are also going to handle the age. The nice thing with the age is that we do not have to do the character limit. So here we have, it's a little bit straightforward. So if age is inside sum, we're going to get the age, and then we'll say hero dot age is equal to age. Nice. So we know that by the time we get to this point, our function has already updated everything that we need. If they change name, it will have the new name. If they change the bio, it will have the new bio. If they change the age, then it will have the new age. Or if they change the whole thing, then it will have the whole data. Nice. So it's looking nice. I think now we have the update function. The next step will be to try to compile and see. I don't know if you guys, someone has left their mic on. Yes. So the next step I want to do is to compile and build. So you can use the terminal here and say Solana. I think it's Solana build, but I want to see it happening in real time. So I'll come here and make use of these buttons. So I'll press build, wait for it to build. Nice, I don't have any errors. And if you notice here, we have this field called IDL. So for the people that are coming from the Ethereum world, remember in Ethereum we have I think it's called ABI, whereby when you compile your smart contract and you build it, it's going to create the ABI. So Solana has something similar. It's called an IDL. So I don't know if I can export it and you guys look at it. So it's always in JSON format. Mark is going to open, it's going to open Xcode anyway. So I hate Xcode. So you can see we have the IDL of the whole contract and everything. This is where the JavaScript is going to happen, where maybe the front end will communicate more of. So we have the functions here. For example, we see we have the rules, we have the character rules, we have everything we need, like, yeah. So we have the create hero function here, and I see we have the system program. Yeah, I think update hero is also here. So yeah, for the people that are coming from the Ethereum world, I think you are familiar with this. So now after we know that our program compiles properly, we can again deploy it. So the cool thing with Solana, it detects when you want to upgrade. So when you make a change and you're using the same address, it can tell you, hey, upgrade. So I want to upgrade. So for the people that are having issues with, maybe you do not have test Sol, you can always come here in the browser, click this, copy the address, and come to the Solana called Solana faucet. Here I think it's the dev faucet, and then you paste it here, select, and then you select the number of Solana that you want, and they'll airdrop it there. And also maybe I think it will be a good time to show you how you can also use maybe from an external address. So maybe let me throw in some money using my Phantom. I have some test Solana in my Phantom wallet, so I'll come here and copy that, and yeah, so Solana has Phantom. Sorry, I've opened MetaMask. Solana has Phantom, and I think they have something called Solfair as their wallets. So let me try to show you how you can get that. So yeah, so currently I'm already connected on test mode, and I have some small Solana here. So you come here, click send, put in there. So I want to earn maybe like 0.5 Solana, and then send. So the moment I put that there, you can see the transaction has already. So here you can see 11 seconds. So now there you can have some money to deploy. So I'm going to use that, and I'm going to press upgrade and deploy and see how we can test our function. So yeah, it has been deployment successful. So you can see here, by the time it deploys, then we can see we have our update hero. So let's try to update a certain hero. So I'll come here. We have, maybe let me add a new hero, then maybe we'll try to update them. So we have the Flash, we call him the Flash. Their name, maybe he's 26, and then we'll say the Speedy Man as their bio, and then we'll give them, because you're creating a new account, we'll give them a random key, a random public key, and then we'll tell it, hey, we are the pair, and then we press to create. Nice. So we've created our hero, and then when you come and fetch all, you see we already have, maybe let me expand this so you guys can see. So you can see here we have the Flash, and when I come and pick their public key, put it here, I can always get that single file. Nice. So I'm going to try to change maybe their name. So I have, let me copy that. So I'll come and collapse that and go to the update hero. So the first thing is going to make sure we have the correct public key for the file that we are going to change, and we are also going to set our current wallet because we are the owner, we are the ones that created them. So maybe I want to change their name from the Flash to Barry Allen, like that. So you notice how it's wrapped inside a string, and when you enter here, it's going to be unwrapped when it enters the contract the other side. So their age, so we'll keep the age as it is, and then maybe we'll change his bio to, hey, new bio, to make it obvious. So the moment we have that, remember we have just changed the name and also the bio. So come here, press that. That was very fast. That was very fast. So come here and you can see we have changed that. So yeah, so you can always play around with that, and even if I change, I can always have that information. So yeah, I think we have basic CRUD. Apart from the delete is something I would like to see you guys how you can achieve that. But yeah, I don't think it's something that is important, because maybe we want to have our heroes to stay on chain and they'll always be there. So I wanted to do some few tests to show you how, unless you guys have any questions, but in these remaining few minutes, I think there are 8 to 9, I want to write some few tests to show you guys how you can test your amazing contracts. So unless if you guys have any questions before I move on from there.
No questions, no questions yet.
Nice. So moving on, inside this playground, it's very nice. I love this playground. It organizes everything for you to the point that it has these test scripts. So for you people in your Windows, you may not have this. You may have something like this. So this is TypeScript. So I'm going to come here and try to see how we can write our tests. So when you're developing locally, you'll have to configure these files here. And it's very easy to configure to be actually. It's just a matter of creating this and running a script. So this is our test script. I had an issue when I was writing the test scripts for these functions. Before we went live, I was trying to test this mutation function, and I found an issue, because remember maybe to take you back, remember the way you create an account, we have to have the signer, and this signer has to pay. So I found an issue in the fact that this test script was not connecting to this account. So there was no way I could sign, because this account was not connecting. It's not as automatic as something like maybe Ethereum does when you call and opens your MetaMask. So yeah, I failed to pull that off. So what I did, I'm going to just write the tests for these fetch functions, and then the other stuff maybe we'll put it in the repo, where we'll have to install Solana Web3.js library, and then maybe people, when you run it from that side, it will be able to open your Sol wallet to sign. So yeah. Speaking of Web3, Solana has a very nice JavaScript library. I think it's called Solana Web3.js. So it is usually what the front-end people use to communicate with Solana. And it has a very nice documentation. You can always look through it. It's very comprehensive. It covers ES6 syntax, and it has the TypeScript world also is also covered. So it creates pairs, it can generate, it can create signers, and yeah, it is something that you may want to look through and see how you can communicate with that. But for this case, the playground is also using Web3, but it is already installed and it's already imported for you, so I won't have to install it there. So for the people that have ever written test cases for their software, or if you've played around with Hard Hat, you're going to find this stuff very familiar. And yeah, so usually we have a very large describe function, and maybe we'll name it the name of our contract, and we'll say our contract is called Heroes, and we want to test everything that is inside this contract using our large describe. So yeah, I'll use an arrow function to keep it very simple, maybe terminate there using the old JavaScript way. So I have to have these blocks of code where I'm going to call, and after calling, it's going to test in batches. So The first test that I want to test is I want to make sure that, hey, this hero can be able to retrieve all the added heroes. Like the retrieve is top notch and it adds there. Maybe if I come here, I know that I have 1, 2, 3. I have 3 heroes. Maybe I'm going to first test to make sure that, hey, when I retrieve the heroes, I must get an array, maybe information that is larger than 0. I must not get an empty thing, or maybe I must get a count of what, how many heroes were they? 1, 2. I think I must get a number of heroes. I think it's 1, 2, 3. I must get a count of 3 heroes. So and it's going to be the first thing that I'm going to test. And the first thing, that the way you can test it is using an it block. So I'll say it should get all heroes. Okay, maybe to make it more descriptive, by not returning an empty list. Nice. So this hero, and I know this is going to be an asynchronous function. I'll put it as an arrow. Nice. So I know this is going to be the first thing. So the way people name it is they use the it, and then it continues as a string of descriptor. So it should get all the heroes. So when I run the test case, it will always show this. Very descriptive. So the first thing that I'm going to do, remember we have this PG. What PG does, PG is like the Web3.js. It's like the Ethers.js of Solana, and it has a very nice function that you can call upon, and then it can be able to index the functions. So remember this IDL, the IDL thing has all these functions. What happens is PG is going to be indexing all the functions that are documented in the IDL, as you're going to see. So we want PG to be an await, because we want to wait for it to come. Want to wait for it to return all the heroes so that we can manipulate it. So PG so the first thing that you need to go to is to get the program of PG, and then after the program you go to the accounts. So you want to access the accounts that are inside that program. So after the program, our first account is hero. So inside here, if we had another account name, maybe it was, let's say we had an account like maybe we had an account called struct, and then we call it maybe universe. And universe, I mean, like, are they an Avenger, are they from Justice League? And then we put it there. When we compile our code, and it will always come up here. So when we click hero, or when we click here, it will come and show universe. So right now we only have one account, and it's the only thing that we can do stuff with. So the fact that we have the hero, there are a very good number of functions that you can play around with. We have fetch, we have fetch multiple, we have get account info, we got problem ID, get size, a lot of stuff. So yeah, it is a very, very vast API if you guys want to go into deep of it, but now I want to keep it very simple and press all. So I'm telling it to get all of them, and I'm going to throw it in a new variable which is called heroes. So I'll call it heroes. Nice. So I know that is set, and then I want to get the count. So maybe I'll say const hero count, and then I'll say heroes dot length, like that. Nice. So I know now I have the count, and I can start asserting in the way I want. So the first assertion I want to make is to make sure that this hero count is not 0. So I'll say assert and then put it in the brackets, and I'll say make sure that hero count is greater than 0, and then I can leave it at that. But you can see here there is this message parameter where you can write a custom message, so I'll make use of it, and I'll say maybe I'll say no heroes were found here. Nice. So I have that. We are making sure that it's not less than 0. So I'll come here, maybe, okay, let's first test that. So we come here, we have these very nice buttons where you can press, but now we want to test this script. So Anchor, this Sol Playground has these buttons. So I'll come here and play and press the test. So you can see it's telling me it's testing it should get all heroes here, and you can see it's passing. So let me write maybe a failing test, and maybe show you how maybe a failing test may look like. So maybe let's make this fail for some reason. So maybe let's say we want it to be greater than 35, of which it's not, but just want to see it failing. Maybe you see how it looks like. So when I press test, so it tells you the message. Remember this message, it puts it here, and it tells you this fail is testing, and it's inside the heroes descriptor and inside this. So yeah, so now we can have that. Maybe I can add the other test case where I want it to be equal to 5. So you can always chain a number of asserts here. So there is also assert dot. So when you have the assert dot equal, it can say, you can have, for example, I want equal hero account and then 5, like that. So also you can have a message here, and then I would say maybe I'll say heroes number did not match. Nice. So we know that. So we try and see if we have written that properly. So you can see here I wrote 5. So here it's already telling me, hey, we expected 3, we got 5. So let me try and put 3 and see if that can pass. So yeah, you can see that test pass is going through, and maybe, I don't know, it's already 8. Maybe I'll add another test so that you can see another test case, so that I can show you the whole picture. So here I'm going to also test for this single function. Remember this one where you can test a single file. So let me try, and I want it to retrieve, maybe I want it to retrieve Batman. So let me come here and copy Batman's information. I'm going to use it sometime there. So I'll come here and I would say it should get Batman's data. Nice. So I'll come here and put it inside an asynchronous function, and the first thing that I'll need to have, remember when you are testing this function, the first thing that you have to have at your fingertips is the public key. So this public key is very, very important. So I'll copy that, and I'm going to put it into a variable. I won't close that so that because I'm going to need it. So I'll come here and maybe I'll say Batman data, maybe put it in an object, and I'll say his public key is this. And then I know that I'm going to need, for example, maybe his name. So I'll keep it very simple. Now I can collapse that. So I know that I have his public key. So the next thing that I'm going to query is the single file using the public key. So I use the same function pg.program, you guessed it, from account, from hero, and then I'll go and use the fetch. So the fetch is telling me to enter the address, which I already have. So I'll say Batman data dot public key, and then I know this is an asynchronous. I'll put it in a wait, and I'll put it in a variable called hero, and I know now I already have that. So now I can assert that. So the first thing that I'm going to assert it against is going to be the name. So the weird thing that this thing does is, I don't know, maybe I'm doing it wrong, but it does not return the public key. I do not know why. Maybe so you look at the fields that it returns, there is no public key and there are no methods on it. So maybe it leaves you with the only option of asserting it with the name, of which is unique. So I think we'll go with that. So I'll come here and I'll say assert. So assert.equal, we'll use the equal, and I want it to match the name here. So Batman data dot name, and then it should be equal to the hero. The name must be the same. Maybe I'll have my message here, and I'll say the hero didn't match. So our test is there, and now I can go ahead and try to test that. So let me first clear the console. I can go ahead and test that. So nice. So it passes. So usually this is the whole architecture of how you build. Most of the time is you write a function, and then you test it out, and then you come back, you extend, and then you test it out as you move back and forth. So it is something that is really, really nice if maybe you are willing to go deeper into the whole system. Yeah, so it is that. I don't know if you guys have any questions before we sign out. I don't know if you have any questions for me. Yeah.
Okay. Just one question, just I have. What is your understanding of context? Like, see, context, yes.
This context?
Yes.
This context wraps what this structure is. So like I said, remember when I said that Anchor has these inbuilt methods that hide away all the complexity. So
Yes.
the other time when you had to pass this structure here, you had to do a lot of stuff. For example, you had to make sure of these rules, like these rules match. You have to make sure you are keeping track of the lifetime. You have to make sure that you're keeping track of all this intricate stuff in the background with Rust. Now you just come here and just throw it inside context and put in the type, and you're good to go. So all the complexity, Anchor does that for you. So I think it's the main reason why I love it as a framework, because it allows you to prototype and build very, very fast before you start to think about now how can I optimize this, how can I change this, how can I trigger and do stuff beyond that. But for the most time, this is more than enough.
No. Okay. Thank you so much about that. I think it's just a
Right?
powerful tool.
Yeah, it's really powerful, and it's built on top of a powerful language. So powerful
That's
stuff.
All right, all right. I think there are no more questions. We are so delighted for you to take us through this entire week. Preparing for a boot camp is not easy. We're very delighted. This is really something I can always come to personally. I always love going back to Bitcoin Lightning tutorials at least and look through. So this is another thing that I have to keep going back through since I'm one of now the Rust people. I really want to explore Rust. So thank you so much. Otherwise, if there's anything else,
Yeah, I'm glad to do that. Hopefully, we can keep on pushing and have more of these in the future. So I'm going to share the information, this repo with the whole updated code. It's going to be in the repo for if there's anyone that wants to play around with the repo. That will be shared inside on the central code socials, so you guys can play around, maybe try to extend it, maybe try to see how things are done. So yeah,
all
otherwise
right. Thank you
everything
so
is
much.
okay. Yeah.
Oh, okay. Let's call it an evening. These days you're good at taking water.
Yes, it is something that I had to learn the hard way. So
I'm also learning from you now.
yeah, yeah, you learn the hard way.
All right. Thank you.
Anyway, thank you guys, and yeah, see you in the next one.
Okay.